In order to verify or prove that two functions are inverses of each other, we're going to use function composition, which we looked at in a previous video. And what we're going to show is that when we plug one function into the other one, everything simplifies out to just be an x. What we want to make sure we do, though, is show the reverse of that as well, and show that that also simplifies to just be an x. So we're going to have two steps to prove that these are inverses of each other. So let's go ahead, and I don't really care which one we do first, so let's go ahead and do our first function composition by taking this, which is our inverse, and plugging in for the x in the other one. Remember, in our previous video when we talked about function composition, we said really all it is substitution. And so what I'm going to do, and maybe if you need a refresher, maybe go watch that function composition video. I'm going to start with doing 3 times not x, but a big blank parentheses and then minus 5. And what I'm going to do is in that blank parentheses, I'm going to write the function I'm plugging in, which is the 1/3 x plus 5/3 function. Okay, and so what I want to do now is simplify this. And what we're trying to show is that when we're done, all we're left with is a single x. So lots of things should start canceling out. So to simplify this particular function or expression, I'm going to start with distributing. 3 times 1/3 x is just 1x. 3 times 5/3 is positive 5. And then I have that negative 5 at the end. And as you can see, the expression x plus 5 minus 5, of course, the plus 5 and minus 5 are also inverses, and all that's left behind is just an x, which is what we were expecting. We wanted to show that this simplified to just be x. So some people say, well, why do you bother doing any work? You know the answer is going to be x. Well, no, since the question this time is to prove or verify something, my answer, quote unquote, is the work that I'm showing. So it's not enough just to say, like, look, it's x. I have to show that it does work out to be x. However, you're not done once you've shown just that. Remember, up at the top we have an and up here. We have to show that two things work out to be just x. So what I want to do is sort of complete the cycle. So this time, let's take this function and plug it into the inverse one where the x is located. So I wanted this to sort of come full circle if you see that circle. Sit up there. So this time, let's start out with 1/3 times blank space plus 5/3. And then within that blank space, of course, this time I'm just showing the opposite. I want to show that original function plugged in. So I want to write in that blank parentheses 3x minus 5. And once again, what I want to show happen is that once I distribute and simplify in any way that I can, I'm left with just an x. So once again, let's start with distributing. 1/3 times 3x is 1x. In other words, the 1/3 and the times 3 have canceled out. And then 1/3 times negative 5 is minus 5/3, negative 5/3. And then plus 5/3. And just like last time, I now have negative 5/3, positive 5/3. Once again, I have inverses. And again, all that's left behind is just an x, which is what we expected. So that is how I'm going to prove that something is an inverse, or that two things are inverses. I have to use function composition. I have to show both directions that each of them simplifies to just an x.